Welcome students. So let us discuss electrostatics in brief. So electrostatics for Neet level, it is very important topic actually. It will give you definitely four questions. Four questions definitely will give you. Of course there are two parts from this chapter. They are, if I classify here itself, they are first force, field, okay, and of course dipoles, fluxes, Gauss law, everything we'll discuss here. Okay, that is part 1, from which two questions you can get. And next, scalars like potentials, potential energy, like potentials is something not correct, okay, potential simply, and of course potential energy and capacitors. Remember, from capacitors definitely one question every year, you can say one question from capacitors, and from the potential energy potentials topic you can get one more question. So total 1 plus 1, here it is 2, and from force field concept again 2 questions will get. So total number of questions that you can get from the electrostatics will be 4 in case of NEET exam. Okay, so let us discuss the part 1. This is the part 1 where force, field and flux can be discussed. Part 2 also will discuss, like it's just a brief discussion only, not the detailed discussion, but I will be giving what topics you have to cover for the NEET exam. Okay, so don't miss this until the end, you can see this. Okay, so first let us discuss a part 1. Where vectors will discuss actually. Force and field, they are actually vectors. In this, first thing you have to understand, Coulomb's law. Everybody knows, even 8th standard students also knows this. Okay, this is Coulomb's law, which is applicable for point charges. If there are two charges which are very less size, okay, say this is Q1 and Q2, and they are separated by a distance smaller meters, then the force of attraction or repulsion between them is directly proportional to product of the two charges and also inversely proportional to square of the distance between them. As a proportionality constant, you will get 1 by 4 pi epsilon naught. And what is epsilon naught? That permittivity of the free space. Based on this, you may get the problems. We will discuss the problems based on this, of course. Okay, so remember, the force is directly proportional to product of the charges, neither addition nor subtraction and division. Understand? It is a product of the two charges. Okay, and this force can be attractive and also it can be repulsive. If it is like charges there, then definitely it is repulsive. Unlike charges, it is going to be attractive. And whatever the formula given here, it is not the vector form, it is just the magnitude. Okay, vector form of the Coulomb's law will be involving the bar over here, and of course here r square is there, and r cap you have to take. Of course you have to take f12 and here r12, something like vector notation you have to take. Okay, that's not very difficult to remember, it's very easy, right? So this is Coulomb's law. Okay, and based on this you can get the problems. Next, after Coulomb's law, like Coulomb's law applicable only for point charges. What if the charge distribution is continuous? Okay, here comes the situation, that is a continuous charge distribution. Continuous charge, discrete charge distribution will be there and continuous charge distribution will be there, both. Okay, if it is continuous charge distribution, there will be 3 kinds everywhere again. First one is a linear charge density, second is a surface charge density, third is a volume charge density. Okay, and linear is lambda, surface is sigma, surface is sigma, volume is rho. The linear is charge per length, dq by dx. Surface is charge per surface area, dq by ds. Rho, that is the volume charge density, charge per unit volume. Okay, and remember, only uniform charge densities they will generally ask for the NEET exam. Okay, for JEE mains level exam they may ask you non-uniform also, but for NEET exam, as far as I have seen that question paper, previous question papers, only uniform charge distributions only they'll ask. Okay, so in case of uniform charge distribution, the charge density equals to total charge by total volume, or total charge by total area here, and here total charge by total length. So let us discuss the further. Let us consider first lambda, that is lambda equals to dq by dx. From here we can say dq equals to lambda dx, and if you integrate it dq, you will have to integrate the lambda also, and you will get two possibilities: uniform charge density, non-uniform charge density. If it is uniform charge density, anyway left hand side of this equation will be del q or q, capital Q. Okay, and right hand side lambda we can bring out of the integration. Okay, lambda into, you have to integrate from limits x1 to x2. So del dx integration will be del x, so x2 minus x1. Okay, so this is very simple and straightforward equation. For example, we can have, consider a wire which has a uniform linear charge density 4 coulomb per centimeters. Okay, 4 coulomb per centimeters, and the total length of the wire is 20 centimeters. Then the total charge contained by the wire, or the total charge of the total wire will be the Q equals to, from this formula we can have Q equals to lambda into del x. Del x is nothing but the gap from where to where we are finding the charge. Okay, if you are finding the total charge on the total length, then you have to take the complete length of the wire. So lambda they have mentioned 4 coulomb into del x is how much? 20. Anyway, centimeters here and centimeters there, it will be cancelled. 420 is 80. So 80 coulomb of charge will be there for the total length of the wire. This is how we have to find the charge with the linear charge densities. Similarly, if you are dealing with a surface charge density, you have to take, instead of dx, you will get ds here. Okay, surface area difference, and if it is volume charge density, you will get dv here. Okay, it's very simple. This is the continuous charge distribution. This is like a brief explanation only. It is not a very detailed thing. Okay, very detailed thing means you have to go for the detailed analysis, right? So for example, in the same way, like if you talk about the surface charge densities, let me give an example here. Consider a disc of radius 16 meters, and the total charge that has been given to the disc is 100 coulombs. Then it will definitely distribute in all possible places like this. Uniformly it will be distributed over the surface of the disc. Okay, and here you should not forget that it has two faces. So on both faces you have to consider the total 100 coulombs of charge has been shared by the two faces of the disk. I mean, one side approximately 50, another side is also 50 coulombs. Now what we are doing, just remove one part of the disk, like for example from the center remove a circle whose radius, the small r, say this is capital R, okay, the small r, say 4 meters radius has been drilled here, okay, this has been drilled, removed. Then how much charge has been removed from that total system? We have to define the sigma, which is constant. Sigma equals to total charge by total area. Okay. So total charge by total area, it is total charge is 100 by total area is A, let it be. Now the charge which is removed by this part, say small q, the small q equals to, similar to this formula, the small q will be, you know, sigma into integral ds, will get, sigma is going to be q by A. Integral ds means the area which has been removed, this red color area which has been removed, that area you have to take, say small a, it is q. Then q by A into small a is what? Pi into small r square. Okay. So radius of the bigger disk is, it is 16 centimeters, 16 meters. And the smaller, the hole we are drilling is 4 meters. Then the ratio is 1:4. Then the area will be proportional to square of the radius, right? So ratio of areas will be 1:16. So the small q that has been removed equals to q by 16, that is 100 coulombs by 16. So this much amount of charge has been removed by drilling the hole over here. Okay, this is how we have to deal with the continuous charge distributions, right? Next, this is about Coulomb's law for discrete and continuous. Okay, in case of discrete, again, you should not forget that if there are only two charges, then only Coulomb's law is applicable. Suppose there are many charges, then how to apply the Coulomb's law? Remember, Coulomb's law, the electrostatic force obeys the superposition principle. Superposition principle. The meaning is very simple. The force due to number of charges on a single charge is the sum of the force due to each charge, and this sum should be vector sum. Okay, so force acting on the first charge equals to force acting on the first charge due to second charge plus force acting on the first charge due to third charge and force acting on the first charge due to fourth charge, and so on, force acting on the on the first charge due to nth charge. Okay, this is also vector. So this is the vector form, like it is the superposition principle of the Coulomb's law. For example, if you have a triangle, so it can be any kind of triangle, maybe equilateral or isosceles or right angle, whatever it may be, and there are three charges which are placed at the three vertices of the triangle, q1, q2, q3, and the lengths are, maybe for the sake of simplicity, let it be equilateral triangle, so a. Now let us keep the charge capital Q at the center of the equilateral triangle. So other than capital Q, there are three charges, 1, 2 and 3. Then force acting on the capital Q will be the force due to first charge plus force due to second charge plus force due to third charge. Okay, this you have to add, and it will be is the net force acting on the center charge. Okay, and how to solve this is a matter of the parallelogram law that we have to discuss. Okay, that I have explained already in another video that you can have. This is discrete distribution, but if there are many number of charges. Okay, and this is about the Coulomb's law. And next, coming to the next topic, important topic of this, the field. Okay, remember the electric field, we believe that it is really existing, and practically it has been tested. Okay, we can't see this, we can't feel physically, but if you send a charged particle into that, it will be accelerated. Okay, charged particle, it can be accelerated either in the direction of the electric field or opposite to the electric field. In which particle will go in the direction of electric field? Remember, positive charge will go in the direction of electric field. Okay, and negative charge will be going in the opposite direction of electric field. For example, electric field is from along the positive x-axis, then the positive charge will go along the positive x-axis, negative charge will go along the negative x-axis. Okay, it's very simple, and electric field definition is very simple again. E equals to F by Q, intensity of electric field, the force experienced per unit charge, it is the Newton per Coulomb. For 1 Coulomb of charge, how much force is exerted? That is called intensity of electric field. Okay, and from here we can say F equals to QE. The meaning of this equation, if you want to find the force acting on the charge, it's enough at the location of the charge, if you apply if you find the magnitude of the field and multiply that field with the charge. Okay, then it will give you the force acting. Suppose the field is 0, then force also will be 0, and the point where the field is 0 is called null point. How to find the null point? There is a process, there is a formula that we will discuss again, but let us first discuss this electric field properties. So electric field, basically the basic definition of the definition of electric field is F by Q, that is Newton per Coulomb, but it depends on charge distribution. Remember, for continuous charge distribution it will be different. Okay, I mean, for a charge which is given along a line, it will have one formula, field will be one formula. If charge is given along a circle, I mean a ring, then it will have different formula again. If it is given along a disc or a plane sheet, then it will have another formula. If it is given along over a space of a sphere, okay, maybe it is a hollow sphere or a solid sphere, then it will have different formulas, various formulas in various situations. Okay, all that formulas we have to remember, and that formula based questions they will give you in the exams. Okay, my intention is electric field general formula is F by Q, but it depends on charge distribution. For point charges, it is K Q by R square. K is 1 by 4 pi epsilon naught. Q is a charge by R square. R is a distance. But for charge distributions, I mean continuous charge distributions, electric field will be different. Like we have to remember that. Okay. And coming to the field lines here. Okay, electric field lines are important. Based on the properties of field lines, they will ask you the problems. Okay. Electric field lines. A field line is a hypothetical line which is drawn from positive charge to negative charge. Okay, the tangent drawn at the point of the tangent drawn to the field line will give you the direction of the electric field at that point. The tangent drawn to the field line will give you the direction of the electric field at that point. Okay, and no two electric field lines should intersect each other. If they intersect each other, then that is a violation of the vector's definition. Okay, electric field is a vector, is not a tensor. If they are intersecting each other, then at the point of intersection for the electric field, two different directions are possible. So only the two field lines should not intersect each other. Okay, this is about the field and field lines. Okay, and for positive charge, the field lines should be diverging. This is positive charge. And for negative charge, the field lines should be converging this way. And remember, as many field lines are present, that much magnitude of the charge is large. For example, if you consider this is 8 lines here and here only 4, and here diverging, so positive, converging, so negative. Since here 8 lines are there, so it is going to be say capital Q, and here only 4 times, then it is Q by 2. Why I am taking 2? Because 4 is half of the 8, okay. So the magnitude of the negative charge here, half of the positive charge, okay, this way. I hope you got it. This is about the field, okay, and I told you already that field formulas regarding various objects you have to remember, right? From there the questions can be asked. Next, going to the dipole. Regarding the structure of the dipole, you know, right, there will be positive and negative charges which are equal but in opposite nature they are, and they are very closely separated but not at the same location, okay. There will be some finite small distance between the positive and negative charges, so that they are not going to recombine each other, okay. That is what actually dipole. The line joining the negative charge to positive charge is called axis of the dipole, and the line perpendicular to the axis is called, axial line is called equatorial line, and the equatorial line must pass through the center of the dipole. And coming to the dipole, there will be field due to dipole, they will ask, okay. Field due to dipole, there are 2 cases: field on the axial line, field on the equatorial line, okay. And of course the third general case also will be there: field at any point r comma theta. Field at any point r comma theta. For example, this is the dipole moment I am giving. Just the arrow indicates the dipole moment p vector, okay. The arrow indicates here it is a positive charge, here it is a negative charge. The center is over here, and the axial line is this line, okay, and equatorial line will be this one. Then if you are finding the field over here, from the center of the dipole you have to draw a line. This is r bar, okay. This is make an angle theta with the axial line. Then at this location the field is given by it is called E of r comma theta. It is given by 1 by 4 pi epsilon naught into P by r cube under root of 3 cos square theta plus 1, okay. So if you substitute theta 0 on the axial line, theta 0, then you will get electric field on the axial line. If you substitute theta 90 degrees, that is equatorial line, then it is going to be theta equatorial, electric field on the equatorial. Remember, the axial field is 2 times the equatorial field line, okay, and very simple. And in the same dipole topic, they will ask, if the dipole is suspended in a uniform electric field. Dipole is in uniform electric field, okay. Remember, if the dipole is suspended in uniform electric field, it will not experience any force. Net force will be 0, but it will experience a torque, a couple, that is Pe sin theta, okay. And it will have some potential energy, that is U equals to minus Pe cos theta, and it will have 2 cases: stable equilibrium and unstable equilibrium, okay. Stable is theta 0, unstable is theta 180 degrees. Remember, the purpose of the electric field is to bring the dipole moment in the direction of electric field, okay. For that purpose, it will exert torque, okay. Due to the torque, the dipole moment will be tilted so that it will be directed in the direction of the it will be directed along the electric field, okay. This is the dipole suspended inside the uniform electric field. This is also important topic, you have to remember. Next, if you go to the flux and how to calculate the flux, this is also important for the Neet, okay. Flux is going to be the dot product of field and area. Simply, it is the number of field lines passing through that area which is perpendicular to the direction of the electric field, okay. And how to consider perpendicularity of that field and this surface. For example, if this palm, if palm is surface you are considering, and the tip of this pen is electric field direction I am taking, then this is a case when they are perpendicular. Okay, remember, in case of a field and area they are perpendicular, the angle you should take 0, because for the surface you will consider the angle from the normal drawn to the surface. Okay, the normal drawn to the surface is this. So electric field is along the line, so only it is 0 degrees. Suppose the electric field is this way, okay, but you have to consider the normal this way, right? Angle between this line and this line is 90 degrees. So only when the field is parallel to the plane, then we have to consider 90 degrees between them. So only flux will be 0 when the field is parallel, and flux will be maximum when the field is perpendicular. Okay, so don't you get confused regarding the perpendicular and parallel conditions of the flux. Okay, and what kind of quantity it is? A scalar quantity. And what about the unit it is? It is Newton per coulomb meter square. Newton meter square per coulomb. Okay, you have to remember the formulas for this. And for three symmetries, for a line and for surface and also for point symmetry, I mean spherical symmetry, you have to remember the flux formulas. Okay, based on the flux, based on this formula, Gauss law of electrostatics it is. According to this, the flux associated with any closed surface is equals to Q by epsilon naught. Okay, the net charge enclosed by the surface divided by epsilon naught. Okay, this is a Gauss law. It's very simple. Suppose there is a hemispherical bowl and here a charge capital Q is placed. Then how much flux is there through this hemisphere? Okay, for this you have to imagine one more hemispherical bowl, because to complete that, to completely close the charge, we need to take one more hemispherical bowl like this, right? Then there are two hemispherical bowls. Then flux through one thing is charge by 2 epsilon naught, because there are two hemispherical bowls. For example, if there is a cube, then on the edge of the cube they have placed a charge. Edge means this thing, okay, this side. On the edge we have placed. Then to cover this charge totally, we need three more cubes. Okay, one is here, another is here, another one will be coming over here. So total number of cubes we need is 4. Okay, then flux through each cube will be total charge by 4 epsilon naught. Okay, why we are dividing with the 4? Because we need the total 4 cubes to cover the total charge, to completely cover the charge. I hope you got it. Similarly, if there is a cube, then on the one face of the cube, for example over here, on one face of the cube we placed a charge over here. Then to cover this we need one more cube like this. Okay, then total 2 cubes are required. Then total flux through one cube will be Q by 2 epsilon naught. I hope you got the clarity on this, and my intention is you should not neglect the Gauss law, and from there you can get the problems. Okay, and next, coming to the next topic, it is once after Gauss law is completed, then field, derivation of the field, electric field using Gauss law, the topic also important. For example, the field due to spherical charge distribution we already know, in case of a field formula you have to remember, but the same thing you have to prove from using the Gauss law. Okay, that kind of analysis also they will ask. I think it is clear for you, and with this we can enter into the part 2 of the electrostatics. Part 2. The part 2 of the electrostatics contains potentials. Okay, and potential energy. You should not neglect this. Potential energy. Symbol is V and U. Okay, the relation between them is very simple. Okay, first potential is W by Q, but the potential difference is equals to potential energy difference by Q, so that work done equals to change in potential energy. Okay, how the problems can be asked from here? It's very simple. Based on work energy theorem, okay, the work done by all forces equals to change in kinetic energy, this formula. Work done by external force plus work done by internal force should be equals to change in kinetic energy. Remember, work done by internal force is always U initial minus U final. Initial potential energy of the system minus final potential energy. Okay, and work done by external force equals to the change in kinetic energy minus U plus U final minus U initial. So this we can say change in potential energy, del K plus del U. This is the work done by external force. Okay, and if there is a chance that the process is very slow, so that del K 0, just an assumption it is, then we can say the work done by external force should be equals to change in potential energy. I hope you got it. Based on work energy theorem, they will ask the problems in case of potential and potential energy, and based on conservation of energy theorem also they will ask conservation of energy. The conservation of energy is very simple. Okay, the initial kinetic energy plus initial potential energy should be equals to final kinetic energy plus final potential energy. Okay, so this is the conservation of energy. And you know, in kinetic energy in mechanics always a simple formula, it is half mv square, half into m into v square. V is the speed. But potential energy in case of electrostatics, it is K Q1 Q2 by R, the formula. The potential energy U12 equals to K Q1 Q2 by R12. Okay, general formula. You should use this. Okay, of course there are two types of potential energies again in electrostatics. One is interaction potential energy. This is called interaction potential energy, whatever I written here. Another is self energy. Okay, self energy. Self energy is something like due to its own charge only, it will have some energy that is called self energy. It will be very simple. It depends on again the shape of the object. Okay, charged body depends, but there will be two formulas: self energy for a shell, for a hollow sphere, and also self energy for a solid sphere. We have to remember that in your textbooks it will be there, the formula. Okay, so this is about the potential energies. And here itself there will be one more important topic, that is equipotential surfaces. Equipotential surfaces, this topic is again important. The problem they will ask, there will be two or more equipotential surfaces, and the separation between the two surfaces also they will mention. And they will ask you to find out the electric field intensity, or simply E value. You should use a relation between E and V, that E equals to minus del V by del R. Negative gradient of the potential, the formula, it is the electric field intensity. This formula you have to use. With this we can say that is equipotential surfaces is important. And coming to the next part, next concept in this same thing, the potential due to various objects, just like the field due to various objects that we have studied in case of field. Okay, field due to monopoles like charges, field due to dipole, field due to spherical charge distributions like due to hollow sphere, solid sphere. Here, whatever the objects that we have dealt for the field, you have to take the same objects and you should find the potential. I mean, potential due to, point charge, it is kq by r. Potential due to a ring of charge, potential due to a line of charge, potential due to spherical charge distributions, maybe hollow sphere or solid sphere, potential due to a sheet of charge, okay, potential due to dipole. So whatever the object that you have studied the field, you have to study the potential also, okay. From the potentials they will definitely give you the problems. And here concentric spheres also sometimes they can ask. There will be two or more, like 2 to 4 spheres will be concentric, and each sphere will have radius r1, r2, r3 and r4, and each sphere will have its different, maybe different or may not be, okay, charge densities they will mention. Then they will ask you to find out the potent charge on any one sphere, okay. For example, the middle sphere is a charge on any one sphere they'll ask, okay. This topic also important. And coming to the dielectric constants, that important topic again. Dielectric constant and dielectric strength they'll ask. Dielectric strength is something, the maximum electric field that can be applied across a dielectric substance so that it will not become a conductor, or dielectric breakdown is not happen, okay. What is dielectric breakdown, what is dielectric strength, what is what, everything that you have to study in the study in your course, okay. Just go for NCERT book or any standard book, just read it. It will be important for the NEET exam. And example for dielectric breakdown or dielectric strength example is nothing but lightning strikes, okay. Like static electricity will be transferred from clouds to the earth. Whenever the air between the cloud and earth is electrified or it is, broken, then it will become a conducting substance, okay. Then static electricity, the charge, excess amount of charge will be going from clouds to the earth, and that process is called as lightning strike, okay. And it is example of the dielectric strength. For example, air dielectric strength is 30,000 volt per centimeters, okay. If you can apply less than 30,000 volts per centimeters, then air will be dielectric substance. If you apply more than that value, then air becomes conducting substance, okay. That means that particular region the air will be conducting. If you put finger in that region, definitely you will get electric shock, okay. Don't you do this. So this is about the potential and potential energies.